Hello to our fellow colleagues, professors, and all others watching this presentation. We are Team F, and our capstone project is a product called Vision. Vision is a web GUI for the York University Robotics Society's Rover. This team consists of 4 members from 3 different engineering disciplines. In this video, we will first explain who our primary stakeholder is and the issues our stakeholder was facing. We will then give a detailed demonstration showing how our product solves these issues. Broader benefits of our product, as well as future plans for our product, will be discussed near the end of this video. But before all that, we must first introduce our team. The 4 members of our team are shown here. Going from left to right, we have Ado, a computer engineering student. Right next to him is Carmit, a software engineering student. After Carmit comes Alberto, another software engineering student. And then there's me, Boomer. I'm an electrical engineering student, and I'll be the one talking throughout most of this video. It is also important to mention our supervisor, Professor Jack. Professor has been a major part of our capstone journey, and he has guided us with his knowledge of agile development processes. We would like to thank Professor Jack, and we are very grateful to have had him as our supervisor. So who exactly is our primary project stakeholder? I know the cool animation at the beginning of the video gives off the impression that our stakeholder is NASA, but that's not the case. Our stakeholder is the YURS, which stands for the York University Robotics Society. The YURS is an organization that educates students about robotics, builds robots, and has fun. They built and developed a Mars rover to accomplish a wide variety of competition tasks, such as equipment repair and servicing, search and rescue, and science, which is all teleoperated from a kilometer away. So what exactly are the problems that the YURS are having with their rover? Well, the issues stem from how they control their rover. Currently, the YURS rover can be controlled using either the command line interface or their proprietary desktop GUI application. This leads to 2 main issues. The first issue is that when it comes to controlling the rover using the command line interface, the rover's operator is required to monitor multiple command line windows simultaneously. The command line interface is not user-friendly, requires more time to operate, and can cause frustration. As seen in the image here, there are 4 different terminals used for data and input commands. Monitoring multiple terminals is a cumbersome and unnecessarily complicated approach to driving and controlling the rover. Here's an image taken in a competition that the rover team participated in. You can see the multiple bash terminals for the input, the command line, and the multiple output windows. This takes a lot of work to control and limits the efficiency of the operator. And I don't know about you guys, but to me, this man looks clearly frustrated. The second issue is the number of devices capable of controlling the rover. Controlling the rover requires the installation of Ubuntu operating system or a VM, the ROS framework, and a whole bunch of other software. Not all laptops have the capabilities and the hard disk space to run these software. The rover team dedicates 1 laptop to controlling the rover. This laptop is seen being held by the man in this video. If this laptop breaks, slows down, or someone forgets to bring it, the rover team will face many problems. In past competitions, when the laptop being used to control the rover experienced hardware issues, the rover team had to quickly reinstall the entire software stack onto another computer before the rover could be controlled. Disastrous experiences like these have taught the rover team that relying on the installation of an entire software stack in order to operate the rover is an inefficient and risky approach. Essentially, YURS is looking for a solution that enables efficient control of their rover on any personal computer or mobile device without requiring the installation of Ubuntu OS, ROS, or any other software. Our capstone project, called Vision, does exactly this. Vision is a browser-based GUI that allows the rover to be controlled on any desktop computer or mobile device without requiring the installation of any other software except the standard web browser. The browser-based GUI provides all the same functionality as YURS's command line interface, is just as efficient as the current desktop GUI, and is fully operational without internet connection. The primary benefits of our web GUI are usability and accessibility. In terms of usability, our GUI is clear and easy to use, has self-explanatory functionality, and unlike YURS's old system, requires no software, programming, or Ubuntu experience in order to operate. In terms of accessibility, our GUI can be used by any laptop, mobile phone, or tablet. This is a huge upgrade from YURS's old system, which required a laptop with a bunch of specific software installed on it in order to be operated. Now, Addo will demonstrate Vision 3.0, the final release of our product.
In this video, we will demonstrate the browser-based GUI for the York University Rover team's Rover. The GUI is decomposed into two large sections, being the main panel, which is what is currently being displayed, and the data panel. Let's begin with the main panel. When the user first enters the application, they are welcomed with a notification at the bottom of the page indicating whether a connection has been established or that the web GUI is currently disconnected from the rover. As you can see, currently the web GUI is disconnected from the rover. When the WebSocket server is launched, the web GUI will indicate that it is now connected to the rover. As you can see, the web GUI is connected to the rover. Beyond connections and disconnections from the rover, the main panel also displays the rover heartbeat and the rover mode component. The rover heartbeat component displays green when the rover is accepting commands from the web GUI and displays red when the rover is unable to accept commands from the web GUI. The rover mode component displays the rover's current mode, either autonomous, teleoperated, or recovery mode, and also allows the user to change the rover's current mode manually. Next, let's discuss the view panel. The view panel allows the user to view the rover's main camera position, as well as to display 4 camera feeds simultaneously. As you can see, the main camera position is being displayed here. Next, the control panel of the main panel houses all the controls of the visual map as well as the refresh button. The map controls allow the user to add and remove waypoints from the map, display the distance between waypoints on the map, as well as pan to the rover's current position on the map. When adding and removing waypoints from the visual map, the location panel on the left of the screen is updated accordingly. As stated earlier, the control panel of the main panel houses the refresh button. If the GUI is currently disconnected from the rover, the refresh button in the control panel allows the user to reconfirm the GUI's connection to the rover. Currently, the GUI is disconnected from the rover. By starting the WebSocket server and pressing the refresh button, the GUI will be connected to the rover again. As you can see, the GUI is now reconnected to the rover. Besides the refresh button and camera control buttons, the control panel contains various other touch controls which in the future can be remapped to provide any desired function. Beyond the main panel, the user can navigate to the data panel by simply clicking the navigation button located at the top of the page. The data panel contains all the rover telemetry data topics in card form, organized by category. In the data panel, the user can view the exact data coming from the rover via ROS. By clicking the button located at the top of the page, the user can navigate back to the main panel. Thank you for watching this tutorial demonstrating the browser-based GUI for the York University Rover Team's Rover.
Along with the specific use of controlling the YURS rover, this application has multiple future implementations and broader benefits. One of the broader benefits will be in the automated vehicle field. With automation becoming a norm in most car and vehicle manufacturing companies, this application can serve as a starting point for an efficient, portable, and reliable replacement for current systems that are often heavy, non-portable, slow, and have high maintenance. This alternative can serve a general-purpose system that can be applied to more industries through further modularization and third-party integration. Another broader benefit would be the integration of rovers into the Internet of Things. Our web-based GUI helps create a more IoT-friendly society, with devices such as Google Home, Amazon, Alexa, Ring, and other such home automation systems gaining popularity. Our application can serve a great connection between the software and hardware worlds. Now, here are some future plans for our stakeholder, the YURS, to evolve our application. Our web GUI is currently catered towards controlling the YURS rover. The robotic operating system, ROS, is the medium that allows the GUI to control the rover. Therefore, in the future, our project could evolve into a GUI that can work for any robot that uses ROS. Whatever will be compatible with it can be monitored and controlled by it. This system will allow users to connect their robot to our GUI and use it for control or moderation purposes. In this case, the GUI would be customizable by the user to fit their specific rover. This includes the other Sumo bots, along with other rover bots used by the YURS. Thank you for your time spent watching this presentation of our capstone project. If you have any questions, please feel free to visit us in our panel.